How are you guys? Welcome back to my YouTube channel. We're still under strength of material N6. We're dealing with tension in cables. We're given the question says the cable in figure 2.8 has a mass. We've given the mass. Right. It's suspended between two, here you see two supports where one is 8 meters higher than the other. Alright, then the maximum tension in the cable is not to exceed 5 kilonewton when the surge is 2 meters, as you can see. So here you have given, this is a catenary cable. As you can see, we don't have a distributed load. Remember, if you don't have a distributed load like this, or if the cable does not carry a load, or so we don't have a suspension bridge, so this is not a parabolic, this is a catenary cables. All right, we have given 2, it's our surge, as they say our D here. This is what it's a surge, 2 meter. This is what it's our height, which is h. We're given this is our span, that is a span. All right, that is what we're given here. We've given 2 supports, A and B. All right, those are our supports. All right, let's see the questions here. Says number 1, you have to calculate the length of the cable. Talking about the length of what? Of the cable, not the span. Do not make mistake. The length of the cable. We want the length of the cable. What is the length of the cable? We're talking about the length of the cable, not span. You want this length. All right, so how can we go about that to determine the length of the cable? All right, we know when we want to calculate the length of the cable, what must come on your mind when we are talking about the length of the cable. There are certain formulas that they should come from your mind. The first formula that consists of what? Of the length of the cable. All right, we have the formulas that consist of the length of the cable. Right, we only have 3 of those formulas that has the length of the cable. The first one is the vertical force. Vertical force, it has consists of the length of the cable, but remember we are working with the half section, but we'll talk about that. We know this is a weight multiplied by the length of the cable, multiplied by the length of the cable. Can say OP example. This is our first equation. You can name it. Is from the can name it the length of the cable. Can take it from O to P. If you want this, you take the half. Remember, from the we take it this from the lowest point. Yeah, we cut it. All right, that is OP. What is another formula must come on your mind is this formula for Pythagoras, right? The one says y b squared plus so equals to must be equals to the length of the cable b squared. OP is in it, the length of the cable OP squared plus yo squared. This is the formula must come on your mind. What is the last one that should come on your mind when that has the length? Remember, I want the one that has the length, the formula that consists of the length. That consists of what? Of the length. Is this one. Also we have the 1x You can say XP, doesn't matter. The formula you still remember, YO, right, multiply by ln YO plus the length OP. You see we have the length there, divided by YO. We have the length, what we're interested, it has the length. The formulas which consist of what? Of the length. Alright, that is what we want. Now we know then to find the final length, the total length of the cable will be X, will be not the length of the one, not the span. I want the length, then you'll add the length of the cable, then we'll have LOB plus LOA. This is your cable, right? Alright, so there's no problem here, but the equations here are the most equations you should keep in mind when you are determining that. This is what must come on your mind. Actually, these formulas. Alright, remember this is where this is a cable, they are supported at what? At a different level. As you can see, this one is higher, this one is low. It does not have the same height. So this equation must come on your mind when you're calculating what? The length of the cable. Alright, so we have those three options. So we check what are we given. So we have given that it says the maximum tension in the cable is not exceed 5 kilonewton. We have given this guy. So that guy will help us where we come. This is a vertical force. Are we given the vertical force? No, we are not given the vertical force. So this is out for now. We want to use it because for now, I will erase that. For now, we don't have that. So YP, that is YP. Do we have that YP? No. Do we have the length? We don't have. One is what we're looking for. YO we don't have, but we can calculate those. Alright, you will see how those formulas will help us, because now we know we have what? The formula that will help us. We can start with this one. Let's go number one. Let's answering this. We know that set YP squared must be equals to YO squared plus the length there, OP squared. Okay, we have this. We have chosen to pick this formula because you're interested on this length. This is what we want of the cable, but we have this. How can we find YP? You ask yourself, how can I get YP? YP is this distance from there till there. Oh, you see, the formula that will help me to find YP is what here? You remember, okay, we have given the maximum tension, right? We remember that that tension at the top, the maximum it's what? The maximum is the same as FT, or can say maximum tension is given by the weight of the cable multiplied by what? By YP, isn't it? So you see, we have the tension, the maximum we've given is 5. The weight of the cable, the weight of the cable, we have what? We have the mass, but we know that mass, the weight will be given by mass multiplied by gravity. So we have the mass there, which is, it is 12, the gravity is 9,81. Then we punch this, we get this to be 117,72 Newton per meter. Anyways, because here it's in kg per meter. So because we have this there, that is what we have. We are punching there, we'll obtain that 12 multiplied by 9,81. You'll obtain that. All right, so we have this now, the weight here. As you can see, since you have the weight, you have this, then you can make this the subject. YP can be equals to what? Will be FT divided by the weight there. We together, we know that we want our YP there. This we have given is 5 kilonewtons. So 5 times 10 to the power of 3 divided by this weight there. We have the weight 117, comma, that. We have 117. We together there, comma, 72. Then we simply punch this. We'll obtain that y or yp will be equals to what? We punch that will be 42 comma 47. This is what it's in mid. We have that now. As you can see, already we have this one here. All right, we have this. As we want to calculate the length, let's make that the subject. If you make yp the length there, make it the subject. You transpose this to the other side, would be y b squared minus y o squared. All right, then we can take the square root both sides. Then we'll have these to be this and this will cancel. We'll have our length there. Our length will be left with the square root of yp squared minus yo squared. All right, we have left with our length. This is length what? OP. So we have this now. Already we did determine what? This guy here. All right, we have that guy. We've substituted yp. Here it's yp 42, 47. 42, 47. We square, since we have the square, minus now yo. Where is this? How can we determine that? We're started there. We must see now our diagram. How can we determine yo? Remember, yo is this one here. All right, you check. We want that yo. Remember, you're working. That means since you have decided to work with yp, that means you are working with this pole. That means we are focusing on this side. We don't work. Yeah, we're working at this side for now. For a little bit, let's ignore this for now. We don't ignore it completely. Just for this calculation, we're focusing on this part, isn't it? So since you're focusing on that part, remember we are using the left side or the right hand side. It's when you are using the calculation of this, you check. All right, that is what we'll be dealing with. You check the side that you want to work with first. Doesn't matter. All right, I want this. How can I relate this? If I can say, you see, YP, I have YP, we did calculate, right? But I have YO. You see this line there? If the horizontal line like this, then I will make this highlighted with green. You see the distance there, also the distance there. You see it's the same. This distance from here, this and this are equal. What I'm trying to say, YP here is equal to this line till to that bottom is equal to that line until that bottom. So you can make equation, you can equate them, that. We see that y, we have YP there. You simply just equate those. You can equate, we have our YP there. Here we say it is equal to this line. What is that? It's YO. This line is starting from where? We have YO, we are going upwards. YO, we're going up. We have the surge there. It's a surge whereby is D. We know that surge is D, whereby is 2 there, plus our surge, which is D. Then we continue, we go, we move upwards. We have our 8, whereby it's H. We know that, plus H. So why I'm doing this is because we are trying to find this guy, the OYO. Now you see we have formulated the formulas to obtain that guy. So we have seen that we have just formulated things. We have just said we have just formulated things around. Then we know that YP is equals to YO plus surge plus our height there. That is what we did there. So we want this. If you make that the subject, you will see what's going on, or you can simply substitute. You can make that the subject of the formula. You take everything, this side will subtract, have YP, you subtract the surge, subtract the height. So now that is how you can find YO. You see, I've taken this step by steps. Why we want this YO, we'll take this YO and substitute there, isn't it? There, so that we'll find this length. That is how it goes. So we find our YO here. YP, we have calculated YP before. Here it was 42.47. Are we together? So we have 42.47 minus surge is 2, we have seen. H, it is 8, we have seen. We are given this here. Subtract those, we'll find out YO is equals to what? We'll have 32,4 47 meters. So we have obtained this. We can substitute here. That is where we wanted this. We wanted to calculate, so that we substitute back here using this equation. We have that is 32 substitute now 32 comma 47. We have to square this since we have the square there, so we can punching this will obtain our length, but it's a length OP. As you can see, I've denoted the length OP. If we have punched that, this length, I just wrote it down there, you'll obtain that length punching all of these. The length there will be 27 375. Obvious, it's a length is measured in meter. All right, we have this. You see, it's a length OP. I'm working with this part is this length here. Remember, we're working from the lowest, the left, the right hand side is one I've chosen. You see, is that length. So, but the length of the cable. The length of the cable is the whole length. Like, you include even this piece. So how can we include even that piece? We have to include even that piece. How can we do that? Because now the total length of this, now we're including this piece, because now this piece is attached where at the pole A, we want even this piece of this cable. So now we have to we want this cable there, because we have to sum up. That means the total cable, we have to add this one and this one. All right, so we can deal with that. Okay, we have our, you come again, it's the same process that you'll do. We want this length, you know, you repeat what you did. There's nothing more special. Again, you just do what we have done, you remember. So you do what you have done. We'll use the same formulas. I was just showing you this, but now instead of B, you'll write what? A. You'll write A here. It does not change now. Instead of B, we'll write A. What I'm trying to say now, instead of that, you'll write A. You can simply say OA now must be equal to the square root, all right, of YA squared minus YO squared. You see, it's the same formulas, but now here you replace where you see A simply B is simply equals to A, just substituting that. All right, we have this. How can I get this A? How will I obtain that A? So that YA, how can I obtain YA? YA, you do the same thing here as you have obtained YB. You do the same thing, but now note, we don't have H here. There's no H. You see where it ends? It ends in there. It's ending at 2 meter, whereby it's a search. We don't have now what H. It's just ending here. You see the distance of this pole is ending there. So you do the same thing. You see, it's the same process. You just take the same procedure. This will be called what? YO plus the search. We'll have the search because we're supposed to say H, but we don't have H here, so you simply like that. We don't have H. As you can see, this distance will be equal to what? To this distance. So YA must be equals to YO plus the surge, whereby is 2. Same formulas. YA will be equals to, that being, we know the surge is YO we did determine before. Previously is this one, it does not change, 32.47 plus the surge is simply 2. So we punch this, YA will be equals to what? 34.47 This is what is DC. It's in meter. Right, we've just added 2 here, obviously it will be 34.47. That is YA. So we have now YA. We want what? The cable. We have this. Remember, we did calculate this now. So we simply just substitute the length OP. There we substitute, we'll have the square root. This is guy 34.47 square this plus this guy YO. We have YO, obviously. Here it is, isn't it? YO is 32.47. Then we square this. What will be the length of OP? Now we punch this on our calculator, the length OP. Let me, here it's minus because we have minus here. This must be minus anyway. Alright, punching this, 34.47 squared minus 32.47 squared. You'll obtain 11.57 meter. So we have this. So we have the length, this length there that I'm highlighting. We have this length like this. Alright, so we also have this length that we've just calculated. So we simply what we'll add to, for us to find this length, this cable, we add these two. Simply add. We'll add now. So the length of the cable, the length of the cable now, just say L. The length of the cable would be the length OA plus the length OP. Obviously we have there, and this is A, is LO, is OA, not OP. AO. Why am I wrote B? Yeah, it's OA. Remember, this is OA. So that length will be 11.57 plus the length OP. The OP one is this one, 27.375. So the total length, the length of the cable, will simply equals to what? Will be 38.945 meter. So this is how you determine the length. I've taken this so long, but I was just explaining. I want you to understand this. It was not that necessary for me to calculate just a simple question. taking long. I'll just do it fast, but obviously you have to understand this. I'll take step by step. So this is how you determine the length actual of if you have given what a catenary cable with the lengths that are placed not aware on the different, if we have a cable on what different heights. This is how you go about determining the length. You understand? So this one is straightforward. Number 2, the horizontal distance between the supports. What is that? We are talking about span. The distance from there between these two. Here is it's L. It's called the span again. 1L. Alright. 1L. So if you have given different support, our span, this span is sometimes is denoted by X. On your formula sheet you'll find it, they call it X, is given by X. They just say X on your formula, but that is the length. But yeah, it's a length, can denote by capital letter L. The small letter L like this, it's a cable, this is a span. So this will be X1. We have X1. You'll understand the left one. We must have two x's when you've given different heights. We have x1 plus x2. If you've given support on this, if you've given the support on the same level, the length will be equals to what? 2 multiplied by x. This guy will be the same when on the what? Same level. If you've given on the same level, but now you're not given on the same level, we should use this formula, this one. So that is a span, is the distance between those. We call it a span. So what is x? How do we calculate this? X is x1. Remember, x1, if you don't know, x1 is this distance. X1 is the distance from there until here. X2 will be the distance from here until there. All right. So, and then the formulas to calculate those x, we know that we have the formulas. It's the same. The formula does not change. So let's find x1. If you want, you can call this, because it's on the, you can call it xa if you want, because it's on this side of the left. It's on the left hand pole, whereby the pole is a. You can call this, because it's on this pole whereby it's b, you can call it b, xb, doesn't matter. You can call it this a, you can call this b, doesn't matter. xa, how do you find xa? The formula does not change. We know y0 multiplied by ln into y0 plus the length of the cable. Since it's a here, will be what? OA. Be careful, that divide by y0. Alright, this is how you determine it. Is the formula. Then the formula does not change. What about xb? Xb will simple yo, does not change. Again, it's still the same formula, multiplied by ln into yo, right, plus the length. Now remember, we have what? B. Here it's xb, so the length of the cable now must be o what? OB. Don't make a mistake there. So we have this, and then we have to add up these things. So we can simply substitute. We can put these things here. Yo, we did calculate yo. We have seen what it's yo. remember YO, we did these things from here. You take all these values that you have calculated before. You see it's 30, 32, 47, all those values. Simply it's a matter of substituting. 32,47 multiply by ln same 32,47 plus the length OA. Check this is correspond with OA will be this one. OA 11,57 we've seen divided by O. YO is this one again, 32,47. Punching that XA, if we punch all of these, we'll obtain that the XA will be 11,34 meter. Same thing, you do it with what? With B. Same thing there. XB, what is this? It does not change. It's 32,47. YO does not change. Multiply by ln. YO does not change. 32,47 plus the length now OP. Here we're talking about OP will correspond with this is 27,375. 27,375 there. Then you divide by 32,47 again. Punching this, you'll have XP to be equals to what again? You'll obtain 24,87 meter. So you add these two, right, to have what? The length there. So we have our span. We have there 11,34 plus 24,87. Then our span will be what? Talking about the span would be 36,21 meter. That is how you go about that. You see, that is how you go about that. That is why you complete this thing. So we know that on 3 says the minimum tension in the cable. We know the minimum tension FH is the same as what? It's the same minimum tension. It's the same as what? FH. It's the same as horizontal. I've talked about this. The minimum tension. I'm talking about F mean, T mean next one. Let me write there. Number 3. T mean, the minimum tension. It is same as the horizontal component, the horizontal tension. It's the one and the same thing, whereby we know how to calculate this. It will be given by what? By the weight of the cable multiplied by that shorted distance multiplied by Y is O. We know that we multiply by YO. That is our minimum, obviously. We know it's here. We're talking about yeah. So The weight of this is the one that you've determined when you are starting this question, whereby we know it was 11, 11, 7. Still remember, comma, 7, 2. We did calculate this, determine, multiply by YO. We have calculated YO. We know that is 32, 47. This will simply give us, your things would have 8. If I punch this, I'll have 3,822 kilonewton. Alright, this is what we have. The horizontal or minimum tension is given by this. Minimum tension or the horizontal tension is given by these formulas. Alright, that's it. So number 4, we have to determine what? Determine the distance from the lowest point. You see this question, I don't know, but this question will be there and then they are the same anyways. They love to repeat this type of, if you can understand what do they mean. They says determine what? Calculate the distance from the lowest point in the cable towards the higher support, where the tension, you've given the tension, where the tension is 4 kilonewton. What does it mean? What does it mean exactly? What does it mean? Remember, this distance that they are talking about, actually they are talking about the x value, right? We know it's a span. We're talking about the C10 span. Let me say, okay, let me rub like this. Let me say from here, I just pick the point from here, yeah, like this. From there, I just pick the point. Maybe I call this point here, let me call it C. I want this span from the lowest point from here until there. I just put it randomly. I'm not sure it's where, but I put it randomly. I want that X there. I will call it XC because I've denoted that point to be C. What will be the span? The distance from this is what they are trying to say. You are wanting that. What will be that distance? That is what they are trying to say. Alright. Then obvious we'll have, for that distance, that means here we have our length of the cable. We'll only consider the smaller part. It's like now we're trying to take, it's like now we have the support, another support here. You can take it as if like we have a support. You understand? So it's like you'll work with this part of this support. It's like we're having a part. It's like this. They've shifted it until there is become a smaller thing. Yeah, you work with something like that. So that means this distance from here till going down, this one will be what? We will be YC. Remember, from that point will be YC. It's like now will be YC. Alright, that is what we have. We want this span X. C. Alright, that is what we want. Those distance, it's a span, or you can say LC, doesn't matter, but we want that. Alright, you understand this question? This point we are not sure. It can be also here, it can be here, doesn't matter. It's like now you're trying, you take this, you shift it towards this side, then you'll have another new span, like new level of the pole. The pole will be here. Obvious, if the pole is here, there will be some shift, but let's consider, we'll call that C anyways. Yeah, we want just that distance. Let me just say I I place another pulley here. Maybe you'll understand if I'm drawing this thing. What they are trying to say is what they are trying to say there. Yeah. Forget about this. Now we're focusing. Forget about that. We are focusing on this now. Alright, we have this distance till there until here. It's our span. But let's call that span XC. Which I will call this C. It's our new pull for that. Already I have A, I have B, I can just say C. Then we'll have the distance of our cable from there until there. Right, so this distance from here until there, we know that will be the height of what we've discussed about, the height of the pole, or yes, they always denoted by Y. Will be Y. You take the letter that you have called this, yeah, that pole, it's YC. This one does not change, will be Y what? YO, obvious, this distance. That is what we have actually. So now this length, that the length of the cable which is denoted by red, will be length what? OC. Remember now this will be OC. It's from O, it's from here until where? There to C. So you see what we have. So do not cram this out. So they want, if you see the question that asks you, says determine the distance from the lowest point, just like this, from the lowest point of the cable, you use that method. They will give you that tension there. Now it's nice because we already have what they say now, towards the higher support tension. You've given the higher support tension. What is the high support tension? Is this one, our pulley there, it's at the high, isn't it? YC, it's at the high. YO, it's at what? At the low. We're focusing on that. So we know how do we determine the tension, or because we have given, does not change. We know guys, we know that the force, because we've given the higher one, that means that will be what? Our maximum again, our maximum force. FT is the same as F max. I've discussed this on my previous video, watch it. So I'll just FT, remember this is the tension, it's a maximum tension there, you can see. But now it's what? FTC. It's FTC, obviously. Specifically must be equals to the weight of the cable multiplied by Y what? Y what? YC, isn't it? We have YC. So we have given this. We have this. So our equation, we want to calculate this distance. The distance here, the span. We know we're dealing with catenary cable. The equation to calculate the span X there, we're talking about that span, that little distance there, that we know that does not change, will be YO multiplied by ln into YO plus that length, because this is what is C. Also this length will be what? OC divided by Y0, like this. We're using this formula. So we'll have to have what? We are using these formulas. The method is that not change. You remember we use this. You remember after this method, remember we'll go to this one of the Pythagoras, but now I'll just say OC, because we have OC. The method does not change. I can say OC, this formula must be equal to the square root. You remember this formula I've shown you, where we get this formula. I can say YC obviously squared minus YO squared. Alright, because Y, when we determine this length, we'll substitute it here. This thing is the same as this first one. There's no difference here. Remember, you understand, it's when we calculated our span. The method that we went through is the same. We use the Pythagoras, that thing, substitute and replace. It's the same thing here. It's the same thing, same process. Alright, so let us determine, it's the same process. We want to take this and substitute there. Alright, but now let us determine YC. Obviously, as like we are used to, we'll have FTC divided by W. Alright, FTC, it's we are given this on the question, will be given here is 4 kilonewton. So we have our 4 kilonewton. The weight of this tension, we know that it's 117.72. Punching this should be equals to, we'll obtain this to be 338. Let me punch now. 333.98 obvious meter. We together 4 times 10 power 3 divided by 117.72. Alright, that is what we have, is YC. Why we calculated YC is because I said the length OC will be equals to the square root of YC squared minus YO squared. So we have OC here, simply going to substitute there. The length OC would be equals to the square root 33.98. We square this minus our that distance YO is the same as the previous one, does not change. We did calculate from the previous, from question 1, we did calculate this thing. We know that it does not change. We know that we're supposed to have our this guy to be 32.47 squared. Then we have the length OC, punching this, we'll have our length to be 10 meter. Alright, we have the 10 meter. So we know, since we have this, we simply substitute there. So we can have SC, we know this will be YO multiply by ln YO plus the length OC divided by YO. YO, we know this will be 32 times 47 multiplied by ln YO 32.47 plus the length is 10 there of this cable. We have 10 divided by 32.47. So we punch this, find that XC, this distance, there will be 9.85 meters. So that is how you go about determining these things. So yeah, this last question here, you must understand your N5, because now we are doing N6, but we did do this thing. It says if the cable is made of copper with the inner steel, remember it's this cable here, it's our cable is made of copper. I'm just doing like this. Alright, it's made of copper, imagine. Alright, it's made of copper here. Let me try and do this. I want to make something. Alright, it's made of what? Of copper. It's our steel cable. I'm making an example. It's made of copper with the inner steel core. At the inside we have steel core. Just see, now we have the steel core. See what we have now. In the inside we have the steel core. We have the steel core. The yellow thing is the steel now. What comes on your mind when you see this? It's a steel. Parallels. Remember, we have series bar and parallel bars. So this is a cable anyways. It contains like this. Let me just write it here. Blue, this is our cable there. But here in the inside part, we have that. Remember now, N5 you did what? Parallel bars and series bars. We have to apply your previous knowledge of parallel bars. This is a parallel bar. It's not a series bar. This is a parallel. Remember, we had series is something like this. This one is a parallel. What do you know about parallel bar? Parallel bars, you must know. What do you remember? The change, remember, the change in extension will be the same, but the total force will be the sum of the two forces. So it's just what you have to remember. Your N5 stuff for in this typical question, that one, it's a parallel bars. Number 5, we are dealing with what? Parallel bars. In parallel bars, you remember that total force will be the force of the steel, because you've given steel, plus the force of what? Of the copper. But remember, the extension is the same. The extension of the steel must be the same as the extension of the copper. These things will extend together. You'll remember that. Alright, so you've given this. Steel core says calculate the stress in each material. You've given Young modulus of the steel is 3. C, E copper and the area of the steel you've given, and that of the steel you've given, and that of the copper you've given the areas. So yeah, then you can go about and determine these things. So we've given, what about the force? Here is the force. Do we have the force? The force must be, use Ft, you know most what is Ft here. Remember, you must keep in mind Ft is a maximum tension. Alright, here is Ft, on the top we've given 5 kilonewtons. You must keep in mind that. So 5 kilonewton times 10 to the power of 3 must be equal to, we have Fs. You know that force, remember from the pressure, stress is equals to force divided by air. So if we want to replace F, we'll multiply, but now will be of the steel, will be the stress of the steel multiplied by the area of the steel, plus either way the stress of the copper multiplied by the area of the kelp cable there. So this is what you have. You have 5,000. So what is the stress of this copper, of the steel. All right, we have given something like a ratio here. Where is it? Where is that ratio? All right, we don't have it, but we have the area. The area is 20 millimeter, right? So yeah, we have that, the SI units. So we have 20, that 20 we will divide it, or it's an area in millimeter squared. If you substitute that, if you use it, because this is in millimeter and this is in millimeter, you can substitute directly because the SI units are the same, but you can also change it if you want. So we know that the stress, I don't know the stress, but we know, I know what, I'll multiply this by what, we know that the area is 20, right, plus the stress of the copper. I don't know the stress of this copper, but I know the area of this copper is 200, isn't it? I know this. So that is what we have so far. So this, we can call this equation 1 because there's nothing we can do now there. So what do we have? We know that the extension is the same. Remember, the extension changing in length of the steel. Remember, this is a parallel, must be called change of the one of the copper, of the cable copper, obviously. So we have this. Remember, what is x? The extension is given by what? Extension is given by what? Force multiplied by what? If we still remember these things, because extension, it has what, you have to remember the extension. But before we can go there, let me just check something here on the top. On the statement, we have something amazing, but here it is. I think this is a nice thing again. Here we have Young modulus of the steel is equal to that of the copper. You see what we have there? We are given that. We've given those Young modulus there. All right. We have that, but anyway, it's fine. All right, then we know that force multiplied by the length divided by area multiplied by Young modulus. What is that? Simply the value of x. We still remember that. So we'll have F, the force for, okay, we have force for the steel multiplied by the length. Remember, in parallel the length will be the same, but doesn't matter. The area of the steel there multiplied by Young modulus of the steel. This must be equal to the force of the copper divided by the area of the copper multiplied by the length multiplied by Young modulus of the copper thing there. So The length we know, remember, the length will be the same. They will extend it the same because the parallel, this and this can cancel. So what is this? Force divided by area. It's a stress. This will be the stress of what? Of the steel. So, but we are left also with this here at the bottom, Young modulus of the steel. What is this? It's simply what? Force over area will be the stress of the copper, but we are still left with what? At the bottom, Young modulus of the copper. Now we have this. This is nice. Now we have, this is what we have. But remember the statement we've given that the stress of the, we've given that the Young modulus here, the Young modulus of the steel is equal to Young modulus of the copper. There we've given 3. Young modulus of the steel is equals to 3 Young modulus of the copper, like this. Alright, so we have to substitute this ratio. Okay, we have to substitute this there. Then you can substitute there. You will have stress of the steel. When I see this, I'll replace that. Will be 3 EC obvious must be equals to stress of the copper divided by EC. So in maths, this is the same, must be cancelled. Alright, so we'll be left with this side with this, with the stress of the steel divided by 3. Here we'll be left with obvious C over 1 is simply the stress of this. Okay, I want can multiply by 3 that side. I'm left with the stress of the steel will be 3 multiplied by the stress of the copper. See what I have now there. Can call this equation 2. This is what I've made now. Now I have the stress of the steel. I can substitute this into equation 1. Substitute equation 2 into equation 1. Just substitute 2 into 1. Alright, 1, remember we have 5 times 10 to the power of 3 must be equals to 2 multiplied by the stress of the steel plus what was this? Why say 2020? It was 20 multiplied by the stress of the steel plus 200 multiplied by the stress of the copper. Here our equation 1, actually it's here. We substitute now. Where I see the steel, I'll substitute 5 times 10 to the power of 3, 20 times. I see this, we multiply by what? 36, isn't it? Would be not, why I say 36? 3, this is not 36, is simply the stress symbol. Let me write it. Okay, the stress C will be 3 multiplied by the stress of the copper plus 200 times the stress of the copper, 5 times 10 to the power of 3. This 20 multiplied by this will be 60 multiplied by the stress of the copper plus 2000 multiplied by the stress of the copper. So at least now we have like terms. Stress of the copper, we simply add. So we have 5 times 10 to the power of 3. It's a matter of adding math now. If you are adding, this would be 260 stress of the copper. That is it, stress of the copper. So I'll divide by 260 Therefore, the stress of the copper, I can just say Cu, but it's the same thing. C, stress of the copper be 19,231 megapascal. Now let's find the stress of the steel using that ratio. Remember that the stress of the steel is equal to 3 stress of the copper. This is what we had, so I can substitute there. So the stress of the steel will be equal to 57,692 megapascal. So this is what it is, guys. So thank you for watching. I know I've recorded this video so long, but I want you to understand that is why I've taken this slowly and step by step. I did not just write so fast, but you see I'm just slowly so that you can grasp everything. You can watch it maybe 20 minutes, then you pause, then you can return back again. You can watch it step by step. Maybe it's not necessary you have to watch it one time, all of this. No, you can take 20 minutes, then later you finish where you have stopped, watch it so that you understand, you practice this. So if you have not subscribed to my YouTube channel, may you kindly click the subscription button and notification button so that you'll become the part of the family. Thank you for watching. All the best. Feel free to like and comment and share this to your fellow classmates.